Good evening, students. Today we'll try to solve the miscellaneous exercise of chapter differentiability from the class 12th mathematics. Let us see how we able to solve the numericals given from the miscellaneous exercise. So I will take the question directly from the exercise from the NCERT. Okay, so let us see how we can solve. Differentiability. Now the topic is the question arises that is from the miscellaneous exercise. Okay, so now we'll try to solve each and every question one by one. So let us see how we can solve them. Now we have the first question here. The first question they have given in this is I have, that is 3x square minus 9x plus 5 whole 9. So this is the function we need to differentiate. How? Let us consider this is as y is equal to 3x square minus 9x plus 5 upon 9 raised to power 9. Now let us see how we able to differentiate them. Okay, so we have dy upon dx is equal to 9 into 3x power minus 9x plus 5 whole power 8 into differentiation of this will be 6x minus 9. Okay, so I can take 3 common from here. So 3 into 9, it will be 27. So we have 8 into, we have taken 3 common, so we have 2x minus 3. So that is how we able to differentiate the function, given function we have. So now let us try to solve the second question. Now the second question is sin cube x. We have the second question, that is sin cube x plus we have cos raised power 6x. So this is the question we have, sin cube x plus cos raised power 6x. How we'll try to differentiate it? Let us see. First of all, first step is, let us consider it is y. The function is equal to y, so it will easier for me to differentiate. Okay, so the function is dy upon dx is equal to 3 sin square x into differentiation of sin x will be cos x plus 6 cos raised power 5x into differentiation of cos x will be minus sin x. So I have this, so I can write 3 sin square x cos x minus 6 cos power 5x sin x. If I take 3 sin x cos x common, so what I will have? I will have sin x minus 2 cos is power 4x. Okay, so that is how we able to differentiate the function. This is a miscellaneous exercise, so it will be bit tougher as compared to the each and every exercise of this chapter, but we'll try to solve and make it more easier so that it will be understood by everyone. Okay, so now we have the third question. So what the third question says, let us see. 5x, we have 5x whole, we can say they have given 3 cos 2x. They have given 3 cos 2x. So now my first step will be, let y is equal to 5x 3 cos 2x. How will differentiate this? Let's try the differentiation process by logarithm, taking log both sides. So we have taking log both sides we have. So now we'll try to solve. How? We have log of y is equal to 3 cos 2x log of 5x. Now we'll try to differentiate this. We have 1 upon y dy upon dx is equal to 3 into cos 2x we have. So the differentiation will try to solve here by product rule. So we have 3 cos 2x. Differentiation of log x will be 1 upon x. We have 5x and differentiation of 5 will be into 5. Plus we have, now leave x 5x and 3 outside. Now differentiation of cos x will be minus. So it will be a minus sine 2x into differentiation of 2, it will be 2. Okay. So my step will be 5. So we have here 3 cos 2x upon x plus, no, it will be minus here. Okay. So we have minus 6 log 5x into sine 2x. Okay. So now the dy by dx will be, in a very simple way, we need to take y on that side. So we have y. So we have 3 cos 2x upon x minus 6 log 5x into sine 2x. So what is y? We can put it here y. 5x whole raised to power 3 cos 2x into 3 cos 2x upon x minus 6 log 5x into sine 2x. So that is how we try to differentiate the function. Now we have in this, what we can do, we can take 3 common here. So we have 5x whole 3 cos 2x, and we have taken 3 common here. So we have cos 2x upon x minus 2 sine 2x log 5x. Okay, so that is how we try to differentiate the function. Now let's go for the fourth question. Now we have just solved 3 questions. So we have solved 3. Now we'll try to solve the fourth. Now we have the fourth question. So now what the fourth question is, let us try to solve sine inverse x root x we have. Okay, the question is sine inverse x root x. Here we can see they have given the condition that x lies between 0 to 1. Sine inverse x root x. So what will be my first step? My first step will be, let y is equal to sine inverse x root x. Okay, now we'll try to solve this. We know that is the differentiation of sine inverse x will be under root 1 minus x square. So this is x. So half 1 plus half 3 by 2. So 3 by 2 whole square we have under root, and differentiation of this, that is the we have, it is 1 plus half, that is 3 by 2. So it will be 3 by 2 x 3 by 2 minus 1. Okay, so we have this. So we have 1 minus x cube into 3 upon 2 sorry and we have x is for 3 by 2 minus 1, 3 minus 2, that is 1 by 2, it will be half. Okay, so we can write this 3 by 2 root x upon 1 minus x cube. This. So that's how we try to differentiate the given function. So we have the next step here is 3 by 2 root x upon 1 minus x cube. Okay, so that is how we try to differentiate the given function. Now let us try to solve the fifth one. We'll try to solve the each and every question from this miscellaneous exercise, so it becomes easier for you. Now we have the fifth question. So what the fifth question says, let us see. We have, that is, cos inverse x upon 2 upon, they have given 2x plus 7 under root, okay, where they have given that x lies between minus 2 to 2. Okay, cos inverse x upon 2, so 2x plus 7, those such question they have given. Now let us see how this complex numerical will be solved. First step is, let y is equal to cos inverse x upon 2 upon, we have 2x plus 7 under root. Now we'll try to differentiate it. So we'll write as dy upon dx. Okay, so we have. So now let's try to differentiate this function with respect to x, that is we have. So let us see what they have given in this. In a very simple way they have given. Now they have, we will use here the quotient rule. So what the quotient rule says, we'll try to differentiate u by v. So dy dx of this will be minus 1 upon 1 minus x square by 4 we have, and into differentiation of x by 2 will be half, minus, now we'll leave as it is, cos inverse x upon 2, and differentiation of this will be half into 2x plus 7 this power minus half, and differentiation of this will be into 2. So it will be reduced by here, upon we have 2x plus 7 half we have here, okay, and now it will take square. So what we have here, we can see here, that is 2x plus 7 under root, we have minus 2 upon 4 minus x square into half. So it will be reduced by this, and minus we have here cos inverse x upon 2. Okay, we have upon 2x plus 7 under root. Okay, and upon I have 2x plus 7. So now what we can do here, we'll take the LCM here. So what will happen, if I take the LCM, I'll got here 2x plus 7 minus, and minus we have cos inverse, okay, we have 4 minus x square cos inverse x upon 2 upon, we have taken this, so we have 2x plus 7 under root into 2x plus 7 into 4 minus x square we have. Okay, so now we have this, so we'll be left with 2x plus 7, we'll take the minus sign common, so we have this is upon I have 2x plus 7 half plus 1 3 by 2 and 4 minus x square. They are a simple question when we try to solve them, but what they have given, that a question looks like that it is very complex, but seriously we can see by differentiating it that it can be solved in a very simple way. So now let us try to solve the sixth question. We have just solved only 5. So now we have the sixth question now. So now we have sixth question. We have just solved 5. And let us see how we'll try to easily solve them. Now we have just solved 5. Now let us see. Now sixth question is given. What they have given in the sixth question, that is they have given cot inverse 1 plus sin x plus 1 minus sin x. Now very simple way they have given 1 plus sin x minus 1 minus sin x. They have given this, and where x lies between 0 to pi by 2. Okay, so they have given this. So now how we'll try to differentiate it? Let us see. Consider is y is equal to cot inverse 1 plus sin x plus 1 minus sin x. We have upon 1 plus sin x minus 1 minus sin x. We have seen that root is given in the numerator and denominator. To solve this, we need to rationalize. Let us see how we can rationalize. 1 plus sin x minus 1 minus sin x. Sign will be changed upon 1 plus sin x minus plus we have 1 minus sin x. Okay. So this is what they have given. Now we can see here that they have given. Now we will see a plus b into a plus b will be a plus b whole square. Okay, a plus b into a plus b will be a plus b whole square. So a plus b whole square. And the denominator we have a minus b into a plus b. We'll apply the identity here, that is a square minus b square. So we have a square minus b square. Okay, so we have this. Now my next step will be a plus b whole square. So we have a square 1 plus sin x plus b square. It will reduce here a square plus b square plus 2ab we have plus 2ab. So 2a plus b into a minus b 1 minus sin square x under root we have upon I have a square and b square, so it will be 1 plus sin x minus we have, so it will plus, if I take it directly, so I will have this. So now we have 1 plus 1 2 plus 2 1 minus sin square x upon I have 2 sin x. Okay, so my next step will be cot inverse 2 will take on 1 plus here 1 minus sin square x will be cos square x and it is under root, it will be cos x. Cos x upon we have 2 sin x. Okay, we have this. So what we will do here? We have cot inverse 1 plus cos x upon sin x. Okay, so now what we can do here, we'll try to apply the formula for cos 2x. We have two identities. We have cos 2x, we have two identities. That is 2 cos square x minus 1. Definitely it will be 1 plus cos 2x is equal to 2 cos square x. If I divide by 2, I will get 1 plus cos x will be, here I can write cot inverse 2 cos square x by 2 upon sin x. I can write as, we use the formula for sin x will be for sin 2x. What is the formula we have? If I write here, that is sin 2x will be 2 sin x cos x. If I divide by 2, so I will get here sin x, I can write here 2 sin x by 2 cos x by 2. Okay, so we have this. So what I will have, that is, reduce this, so we have cos x by 2 upon sin x by 2. I can write as cot x by 2. Okay, so we have this. Now we'll have x upon 2 is my answer. Okay, so as it is, we can use the formula and different identities to solve such kind of numerical. So we have this, that is y is equal to x by 2. Now we need to differentiate this function, so we got dy upon dx is equal to half, because differentiation of x will be 1. So that is how we able to differentiate such kind of function. So now I hope it's clear to everyone. Now we'll try to solve the 7th. We have just solved only 6 numericals. Now we'll move on to the 7th numerical. So now let us see. what the seventh question says. The seventh question is, we have log x, that is power log x, where they say x is greater than 1. So we have log x is for log x, that is x is greater than 1. So now let us consider this first step, that is let y is equal to log x as power log x. Now let us try to differentiate it. Sorry. Now let us try to differentiate it. How? By using logarithmic differentiation, taking log on both sides. Taking log on both sides. So we get, that is log of y is equal to log of log x. We have, okay. So now differentiating with respect to y, with respect to, we will say with x, we get. How? Let us see. 1 upon y, dy upon dx, it will be, differentiation of this will be log x. We will apply the product rule, that is log x. So we have differentiation of this will be 1 upon log x. Okay, 1 upon log x into differentiation log x 1x plus, using this we'll leave it as log x, log of, sorry, we'll leave it as it is, log of log x into differentiation log x will be 1 upon x. So we have dy upon dx, so it will be reduced by this, is equal to y, taking y that side. So we have 1 upon x plus log of log x upon x. Now what is y? Y is log of, we have y, that is log of x, we have y, that is log of x, this power log of x, we have 1 upon x plus log of log x upon x. Okay, so that is how we try to differentiate the function using logarithmic. Okay, so we'll try to solve now. Next question I have. So what the next question says, let us try to write it. We have 8 questions here. So what the question says, cos a cos x plus b sin x, a cos x plus b sin x for some constant a and b. Okay, so they have given this, that is a cos x plus b sin x. So now let us see how we can differentiate. First step will be, let us consider y is equal to cos of a cos x plus b sin x. Okay, so they have given this function. Okay, so let us see how we'll able to differentiate this. Now let us see how we'll try to differentiate. Differentiation of cos x will be minus sin x. So we have minus sin a cos x plus b sin x. Now what we can do, a differentiation of this will be minus a sin x plus b cos x. So we have this. Okay, so we can consider this as minus a, we have, no, we will take this side, so minus a sin x plus b cos x, sin a cos x plus b sin x. Okay, so that is what we have. We can multiply minus inside, so we have a sin x. Okay, we have, that is minus sign is there, so it will be a sin x minus b cos x into we have sin a cos x plus b sin. Okay, so that is how we able to differentiate the given function. Now we'll try to solve the ninth question. We have just solved only 8 from the miscellaneous exercise. Now we have the ninth question. We have just solved 8. Now let us see what the ninth question says. We have the ninth question here, that is, they have given sin x minus cos x. We have sin x minus cos x. Now what we can do here, they have given also, that is, x lies between pi by 4 to 3 pi by 4. Okay, so that is they have given. So now we'll try to differentiate the given function as it is. Now we'll try to differentiate this function. How? Let us see. Let y is equal to, we have sin x minus cos x upon sin x minus cos x. Okay, how I'll differentiate this function? In a very simple way. Take log on both sides. Log on both sides. So now we get here, that is, log of y is equal to log of sin x minus cos x, sin x minus cos x power. This is given in the power form. Now how to solve it? Now very simple way, differentiating it now. Differentiating it with respect to x, we have, that is, 1 upon y, dy upon dx, it will be sin x minus cos x. Differentiating this, differentiation of log x will be 1 upon x. So we'll have 1 upon sin x minus cos x into differentiation of this will be cos x plus sin x. Okay, cos x minus we have sin x. Now we'll leave as it is. We'll differentiate this. So we got plus, we have cos x plus sin x, and it will be same. We'll write it as log of sin x minus cos x. So it is how we have tried to differentiate this. Now what do I have here? It will reduce by here. So we'll take this common, that is. So we'll have 1 upon y, dy upon dx, we'll have cos x plus sin x. I've taken common, so we have 1 plus log of sin x minus cos x. Okay, so now what will be my next step? I will take y to that side. So therefore dy upon dx will be y into this cos x plus sin x, 1 plus log of sin x minus cos x. So now what is y here? What is y we have taken? This. So we'll write this sin x minus cos x, sin x minus cos x. Okay, and this will be written as it is, cos x plus sin x, we have 1 plus log of sin x minus cos x. We can't solve further. Okay, so we can leave it as it is. Okay, so that is how we try to differentiate a given function. Now we'll try to solve more numericals from the miscellaneous exercise. We have just solved 9. Okay, so now let us see. We'll try to solve the 10th question now. So what the 10th question is, let us try to write it we have the 10th question here, that is x is power x plus x is power a plus a is power x plus a is power a. Okay, and they have given for some fixed a is greater than 0, also x is greater than 0. Okay, so they have given this. So now we'll try to differentiate. Now what, how, let us see. Let y is equal to x power x plus x power a plus a raised power x plus a raised power a. So we'll differentiate it. We got here, we'll differentiate this. So we have x into divide dx of x. Okay, how we can differentiate it? What we can do here, if I differentiate this directly, I got 0. I got a raised power x log of a, and here if I say, it will be a raised power x a minus 1 plus, and this will be x raised power x. How will differentiate it? Will try to take it as u. Okay, so we have y is equal to u. So we have, sorry, no, not this. We'll consider this u is equal to x power x. So we have given u here. So what we can do here? Take log. So log of u is equal to log of x power x. So we have 1 upon u du upon dx. We'll consider this as u. So we'll have du upon dx. Okay. So they have given 1 upon u du upon dx. This will be x into differentiation of log x will be 1 upon x plus log x differentiation of x will be 1. So we have log x. So we have this. Okay. So like this we can do it. Now what is left here? We'll take u there, u into 1 plus log x. Now what is u here we have taken? So we'll have x power x 1 plus log x. So now we'll put this value here. So we have, therefore dy upon dx will be x power x 1 plus log x plus we have a x power minus 1 plus we have a raised power x log of a. That is how we try to differentiate. Now let us try to solve more numericals given in the miscellaneous exercise. So we have just solved 10. Now let us try to solve 11th now. So what the 11th numerical says, let us see. So now we have the 11th question. So what the 11th question is given, that is x square minus 3 and plus x minus 3, we have power x square. Okay, they have given for x is greater than 3. Okay, so they have given such kind of question. As it is, we know that this is the miscellaneous exercise. So miscellaneous exercise not always have tougher questions. They may have easier questions, but they show like that is they are tougher to solve. So now we'll try to solve them as very easily. So what we can do here, first step will be let y is equal to x square minus 3 plus x minus 3 x square. Okay, so now we have this. Let us see how we solve it. Now let us see how we can solve it taking log on both sides. What we can do? Taking log on both sides. We have. So what we can do here? Taking log, we have log of y is equal to log of x square minus 3 plus we have log of x minus 3 x square. Okay, so now we'll try to differentiate. We'll write it as differentiating with respect to x we have. So what we have, let us try to solve. 1 upon y dy upon dx, it will be x square minus 3, x square minus 3 we have, into differentiation of log x will be 1 upon x, plus leaving as log x, we'll take differentiation of this, will have 2x, okay. So plus simply we have x square, and differentiation of log of it will be 1 upon x minus 3, and differentiation of x minus 3 will be 1, okay. We have this. Now what we will do here, that is we have differentiate here x square minus 3 into differentiation of log x, plus then we have log x, it will be, so same here I will do it, we have x square into this, so differentiation of this will be, okay, and now plus I have will leave it as it is, and differentiation of x square will be 2x log of x minus 3. Here I have applied the product rule, okay. So now what we can do here, let us see, we'll have dy upon dx will be y into x squared minus 3 upon x plus 2x log x, plus we have, that is, let us try to solve it in our simple way. We have 2x log x plus we have 2x log of x minus 3 into x square upon x minus 3. Okay, we have this. So what we can do here, in a very simple way, we need to keep it is as it is. We can take only 2x as common. So what is y? We'll write 2x square minus 3 plus we have x minus 3, x square we have, that is y. Now here I will write as it is x square minus 3 upon x plus 2x log x plus 2x log of x minus 3 we have into x square upon x minus 3. Okay, so that is how we try to differentiate the given function. Now we'll try to solve more numericals so that it become easier for us to understand this miscellaneous exercise. Now let us try to solve 12th question. Now we have just solved only 11. Okay, so now we'll try to solve more questions here. Now let us try to solve, we have 12th question here. We have just solved 11. Now let us see what the 12th question says. We need to find the dy upon dx. Okay, if they have given y is equal to 12 into 1 minus cos t, okay, and they have given x is equal to 10 into t minus sin t. Okay, they have given this, and also they have given, that is, t lies between minus pi by 2 to pi by 2. Here we need to find the dy upon dx. Okay, so they have given the function in parametric form, so it's easier for us to calculate. How? First we'll calculate the dy upon dt. So it will have 12 into difference 1 0, it will be sin t. Okay, and we have dx upon dt, we have 10 will leave outside, so we have 1 minus cos t here. So now what we need to find, that is dy upon dx, that it will be dy upon dt upon dx upon dt. So that we have 12 sin t upon 10 into 1 minus cos t. 6, 5, so we can put 6 upon 5 outside. We have sin t upon 1 minus cos t. So that is how we try to differentiate the function as it is. Furthermore, what we can do here, we'll try to put the formula here. Okay, so let's try to put the formula here. We have 1 minus cos t, it will be 2 sin square t upon 2. So I have this, so we'll have, that is 6 upon 5 cot t upon 2. How? We'll try to explain it. Here I have put the formula for sine 2t, that is 2 sine t cos t. But if I put here by 2, what will happen? So it will be sine t is equal to, I can write here 2 sine t by 2 cos t by 2. But how? But now the next is 1 minus cos t. We know the formulas for that. 1 minus 2 sine square t. So if I take this and that side, so we'll have 2 sine square t is equal to 1 minus cos 2t. Okay. So now I can put 1 minus cos, if I take 2 here, so 1 minus cos t I can write 2 sine square t by 2. Okay. So by using such kind of identities, we can easily differentiate the given function. Now let us try to solve the 13th question. We have just solved only 12. Okay. So now let us see what the 13th question says. Now we have the 13th question. So what the 13th question is, let us see. That is, we need to find the dy by dx. They have given y is equal to sine inverse x plus sine inverse 1 minus x square. Okay, and they have given that is x lies between 0 to 1. So now we need to find the dy upon dx. So now let us try to find it. That is dy upon dx, it will be 1 upon 1 minus x square under root, we know that differentiation of sine x, plus we'll try to differentiate this, so we have 1 minus x square we have. So now this is the x we have, so it will be x, we have x square, okay, in the under root we have. So it will be inside they have given, that is in the root they have given, into differentiation of this will be half 1 minus x square under root into 2x. Okay, so we have 0, it will be minus 2x here, so it will be 2. So we have 1 upon 1 minus x square under root plus, now we'll try to solve this, we have 1 minus 1 plus x square under root we have into minus x upon 1 minus x square I have. So we have this, so it will, we can say 1 minus x square under root plus x square, it will have 1 upon x into minus x upon 1 minus x square under root. We have this, and now what we have, that is 1 minus 1 upon 1 minus x square under root, it will be 0. Okay, so that is how we try to differentiate the given function. Now let us try to solve the 14th question. Okay, we have just solved 13th, now we'll try to solve 14th. Now let us try to solve the 14th question. We have just solved only 13. Now they have given x into under root of 1 plus y into under root of 1 plus x is equal to 0. So they have given this, and they are saying that x lies between minus 1 to 1. Okay, so now we need to prove that dy upon dx is equal to minus 1 upon 1 plus x whole square. So first in this function we need to find dy upon dx, then we'll see that we are able to prove it or not. So now they have given this function we have. So now how we'll find? We'll try to solve as it is. Minus y 1 plus x. Now squaring both sides. I have taken this to right hand side, so it will become negative. Now we have, that is squaring both sides. So what we have? Squaring both sides, x square 1 plus y and y square 1 plus x we have. So we have this. Now we'll try to prove it as it is. Now what will be the next step will be, will multiply inside. y is equal to y square plus xy square. We'll take that side, x square minus y square. We have xy square minus x square y. Okay, so we can take x minus y, x plus y. We'll take xy common here. We have, it will have, y minus x. Okay, so we have taken xy. Now we can write this as x minus y, x plus y. We'll take minus sign common. So we have x minus y. So it will be reduced as x plus y is equal to minus xy. So x plus y plus xy. So y plus xy is equal to minus x we have. We'll take common as 1 plus x is equal to minus x. So y is equal to minus x upon 1 plus x. Now we'll try to differentiate this. So we have dy upon dx. So we'll have 1 plus x, differentiation of minus will minus 1, minus here minus x we have. Okay, or what we can do, take minus sign as, so we will try to solve it. Is 1. So we have minus x into differentiation 1 plus x will be 1 upon I have 1 plus x whole square. Okay, so now if I open this, 1 plus x minus x minus I have 1 plus x whole square. We have minus 1 upon 1 plus x whole square. So that is how we need to find dy upon dx value here, and what we need, or we can say what is required, that is we need to prove that is dy upon dx will be this minus 1 upon 1 plus x whole square. So that is how we able to solve the numerical. Now let us try to solve one more. We have just solved only 14 from the miscellaneous exercise. Now we'll move on to the 15th. So let us see what the 15th question says. Now let us try to solve the 15th. So what the 15th says, they have, that is x minus a whole square plus y minus b whole square is equal to c square, and they have given that is c is greater than 0, and we need to prove, what we need to prove is 1 plus dy upon dx whole square raised power 3 upon 2 upon I have d2y upon dx square. Okay, we need to prove this. Okay, we need to find this. So where it is a constant, is constant independent of a and b. Okay, we need to prove this, that I will solve this, and in this we have the answer which will be independent of a and b. So that is the question we have. We have a lot more questions to solve. So now let us see how we are able to solve it. Now let us try to differentiate this function. We have 2 into x minus a plus 2 into y minus b dy upon dx. It will be 0. So now 2 into x minus a is equal to minus 2 into y minus b dy upon dx. So it will have, so therefore dy upon dx will be minus of x minus a y minus b. So we have this. So now we'll try to differentiate it again. So we have d2y upon dx square. So what we have, we'll try to put it as it is y minus b into differentiation of, so it will be 1 minus x minus a into differentiation of y minus b. So if I try to differentiate this, so it will be dy upon dx. Okay, so you have dy upon dx here, and upon I have y minus b. Okay, upon I have y minus b whole square. So now we'll try to find it as it is. So we have minus y minus b whole square. We have minus of x minus a dy upon dx. It will be y minus b whole we have. So it will be y minus b whole cube. So we have this. Okay. So now we'll try to find it. We have dy upon dx and dy upon dx square. We'll try to put both values here. Okay. So let us see how. Now let us try to put the value here. So what we have, let us see. So now what we can do here, minus y minus b minus x minus a. Now what we'll do, we'll put value of dy upon dx here. So we have minus of x minus a on y minus b we have. So now we have this upon y minus b whole square. Okay. So now what we can do here is minus of y minus b minus plus it will be x minus a whole square and upon y minus b upon y minus b whole square we have. So now what will happen here, that is, we'll take as it is. So y minus b whole square plus x minus a whole square upon y minus b whole cube I have. Okay. So I have this value. Now we'll try to put the value of dy upon dx and d2y by x square in this section. Okay. So we have. Now we know that this value is equal to c square. So it will be, so now we have d2y upon dx square will be minus c square upon y minus b whole cube. Now we'll try to put both these values in this. So we have 1 plus we have minus of x minus a upon y minus b whole square. So here I will try flower bracket. Okay, so I will try to solve this. Upon I have this minus c square upon y minus b whole cube. Okay, so now I have this. So 1 plus dy upon dx whole square. So I have got this. So we'll try to put 1 plus x minus a upon y minus b whole square upon minus c square y minus b whole cube. Okay, so now we'll try to solve here. So I got y minus b whole square, upon it will be, if I square is there, na? So if I take y minus b whole square, here I have y minus b whole cube upon c square. So now I can see here, that is x minus a whole square plus it will be c square upon we have this. No? So now what will happen if I take the square of this? So I have y minus b. Okay, so now I have whole cube into y minus b whole cube upon minus c square. So it will have, we have the value here, that is will be minus 1. That is independent of a and b, what we need to find. Okay, so that is how we'll try to solve. Okay, now but they have given here, that is whole 3 upon 2 they have given. No, this much only they have given. So now let us see what will happen. So it will be 3 upon 2. So now if I try to put it, so we'll have this value, okay, upon d2 of y upon dx square. So it will be this, and now we have try to solve this upon 1 minus b whole square we have. Okay, so it will be cube. So now it is 3 upon 2 here, so it will be cube here, so it will be reduced. But now let us see if it is c square and whole we have 3 upon 2, so it will be c cube upon it will be c square we have. Okay, so they are reduced. Now we can say that it can become minus c. So it comes independent of a and b, which is required to solve, or they have been asked to solve. Now let us try to solve another question we have, that is 16 now. So what the 16th question says, let us see. We have the question in my hand I have. So now I hope it's clear to everyone that these are the miscellaneous exercise questions. They just look like complex one, but when we need to try to solve them, what we get, everyone knows what we get here. That is what they have, that when we try to solve them, we find it more easy. So that is how we solve. Now let us see, we have 16 question, that is they have given cos y is equal to x cos a plus y with cos a is not equal to plus minus 1. Okay, and with this we need to prove, what we need to prove, that dy upon dx will be cos square a plus y upon sine. Okay, we need to prove this and they have given this. So let us see how we able to solve it. So now let us see how we can solve this function. You can take x is equal to cos a plus y upon cos y. Now while differentiate this function with respect to y, we have cos y, differentiation of this will be minus sine a plus y, minus we have cos a plus y, and differentiation of cos y will be minus sine y. Okay, so now what we have, this upon we have cos square y. So now what we can see here, that is they have given that we need to prove this. So we have find this, that is x will be, oh no, I have written, so it will be like this, no, cos y upon cos a plus y, sorry, it will be like this. So cos square will be a plus y. Okay, so now we have, what we can do here, we'll try to solve this cos, remove all this, so it will become easier for us to put. So we have cos y differentiation minus sine y, we have cos a plus y minus, now we have cos y and differentiation will be minus sine a plus y we have. Okay, so we have this. So now what I can write this, minus sine y cos a plus y plus cos y sine a plus y, cos square a plus y. Now we know the formula here, that is sin x cos y minus cos x sin y, it will be sin x minus y. So we will write sin x minus y. We have this upon cos square a plus y. This identity we have learned in class 11th. That is, I can write here, that is sin x cos y minus cos x sin y, it will be sin x minus y. Okay, so that is how we try to differentiate this. So now therefore dy upon dx will be cos square a plus y upon sine a. Okay, so that is how we try to differentiate, try to prove. So finally we able to prove this. So we can write in this, hence proved. Okay, so that is how we able to prove. I hope it's clear to everyone. Now let us try to solve the 17th question. We have just solved only 16th. Now we'll try to solve 17th from the miscellaneous exercise. So we see what the question is given in this, that is 17th question they have, that is x is equal to a cos t plus t sin t. Okay, we have this, and y is equal to a sin t minus t cos t. So this they have given in the parametric form, and we need to find d2y upon dx square, a cos t plus t sin t plus, and y they have a sin t minus t cos t. So now let us try to see how we can solve it. The function is given in the parametric form. So let us try to solve. Now dx upon dt, it will be minus a. So now I will not take this. So minus sin t plus, will apply here product rule, that is t into sin t will be t cos t, plus I have differentiation of t will be 1. So now we have only sin t here. Okay, so now we have this, and if I try to find dy upon dt, it will be a cos t minus t into cos t, that is plus t sin t. Okay, and now minus, because I am applying a product rule, so it will be plus, but as we have minus outside the bracket, so when we multiply the minus bracket inside, so it will be minus. So now minus, so differentiation of t will be 1, so we have cos t here. Okay, so this is what we have. Now what we can find, dy upon dx, it will be dy upon dt upon dx upon dt. So what we have here, a, that is cos t. Okay, so it will be reduced. So I have now left with t sin t upon t cos t, and we have a here, so it will reduced, so it will have tan t. So we find dy upon dx is tan t. Now what we need to find is, that is we have find is dy upon dx, we have this. Now we'll try to solve d square y upon dx square, it will be sec square t and dt upon dx. Okay, so that is how we try to differentiate the given function. Now in this we find the value of dt upon dx from here, and we'll try to put. So we have sec square t upon dt upon dx, it will be at cos t. 1 upon cos will be sec, so I have sec cube t upon, so I have here sec cube t upon 80. So it is how we able to differentiate the function. So we have just solved 17 questions. Now we'll try to solve the 18th. So let us see, we have, okay, but we have the question, that is 19th. Now we'll try to solve. Okay, so now let us see how we can solve such kind of question. We have, we'll try to solve now 19th instead of 18th, because 18th question is from the continuity. Okay, but we are just solving the question on the differentiability first. So because we know we can solve easily by continuity. Now we'll try to solve the question, that is 19th question. What they have given, we have to use the mathematical induction, what we have studied in class 11th. Okay, so now what they have given, we need to prove that differentiation of x power n will be, that is nx n minus 1. Okay, for all positive integer value of n we have. So now let us see how we able to differentiate such kind of function. Okay, so let us see how we can do it. Now we have this. So how we'll try to solve this numerical using mathematical induction. So we have let Pn be the given statement we have. Okay, statement. So now we have Pn is equal to d by dx of xn is equal to nxn minus 1. Okay, if we have P1, so we have x power 1 is equal to n into x power 1 minus 1, n into x power 1 minus 1, 0, we have n. Okay, so we have this. Now if I try to prove for pk, so it will be d by dx of x power k is equal to n into x की power k minus 1. If I try to prove for pk plus 1, so it will be d upon dx of p will have, that is x power k plus 1, we have x n here. So now we'll try to prove it. It will be here we have 1. Okay, so it will be 1 into 1, it will be 1. Now for pk it will be this we have, and now for k plus 1, now I am trying to prove it. So it will be x into k plus 1 minus 1 into k we have. So what will happen? So we have this value, that is x k plus 1 we have, that is here we have k plus 1. Okay, so we have k plus 1 this power x this power k I have. Okay, so now I can multiply it. So I found x is power k plus we have k x power k. Okay, so we have this. Now I will try to solve this. That is, we have x power k plus k x power k I have. So now I can try to, we have, will take the d by dx of this. Now we have here, it will be x power 1. So now we can write d by dx of x plus 1, x into k power plus 1 is equal to x into k into x d by dx. So what I will have here in a very simple way, x into differentiation of x power k d by dx of x power k plus x power k d by dx of x. So we have, now we have, so it will be kx into xk minus 1 plus we have x power k. Okay, so I have this value. So now we can have as it is. If I multiply this, I got k into x power k plus x power k. It will be x power k plus 1. I have this. Okay, so finally I found the value of this. Now I can write this as x power k plus 1 minus 1 into k plus 1. Okay, so we can say that pk is plus 1 is true for pk and also for p1. Okay, so we can say that pn is true for n belongs to natural number. So that is how we try to solve this numerical using the mathematical induction. Now I hope it's clear to everyone. Now let us try to solve another numerical we have. I have solved 19th. Now we'll try to solve the 20th. Okay. In this exercise, we have just skipped only 18th question. Okay. So now we'll try to solve the, that is 20th. Okay. So now what the 20 question says, they have given, that is sine A plus B is equal to sine A cos B plus cos A sin B. Okay, so this is a formula we have to use, and we have to differentiate it to find some formula for cosine. So how? Now let us differentiate both sides. Okay, differentiate with respect to x we have. So we will try to solve d by dx of sine A plus B is equal to d by dx of sine A cos B plus d by dx of cos A sin B. Okay, so now let's try to differentiate. We have cos A plus B is equal to, if I try to differentiate, I got sin A into sin B plus cos B. Differentiation of sin A will be cos A plus cos A into differentiation of sin B will be cos B. Cos A cos B plus sin B into differentiation of cos A will be sin A. Okay, but here it will be negative. So we can see here it will be reduced here. So we finally find the formula that cos A cos B plus, we have here cos A plus cos B plus cos A cos B. So we find here the formula for cos A plus B. So we can differentiate it by taking as a function of t. So if I take this function as a differentiate of t, so here I will apply as dB upon dt plus I have cos B cos A dA upon dt plus here cos A cos B dV upon dt and minus sin B sin A dA upon dt, and here also we'll try to put dA upon dt plus dB upon dt. Okay. So now I am trying to differentiate this function with respect to t. So I have, so now we'll have, okay, so we have this sin B. So now what we can do here, we know that if I try to solve, we have cos A cos B cos A cos B minus sin A sin B. So take dA upon dt plus dV upon dt. Okay, because now I am taking here A and B as a function of t. So we'll try to differentiate with respect to here t I have. So I have cos A plus B dA upon dt plus dV upon dt I have. So I have this, that is cos A plus B is equal to cos A cos B minus sin A sin B. So that is the formula for cosine. So we can easily differentiate the function of sine to get the function of cos, formula for cos that we have asked. Now let us try to solve another question. Now we have solved 20. Now we'll skip 21 and we'll try to solve 22 first. Okay, so now let us see how we able to differentiate. How we'll try to find the function what they have given. Let us see. Now we'll move on to 22 question now. So we have the 22 question, what they have given is y. Okay, so they have given if y is f of x, g of x, h of x. Okay, they have given the question on determinant. We have studied determinant. Okay, that's the third chapter. And now they have given this, and we need to prove that is y dash will be f of dash x, g of dash x, h of dash x. What they have? L, M, N, A, B, C. So we need to prove this. So let us see how we able to prove such kind of questions. Now we have this. So dy upon dx will be d by dx of fx, d by dx of gx, and d by dx of hx. We'll have L, M, N, A, B, C. I have. So here I will have plus. We have fx, gx, hx will have 0, 0, 0, A, B, C, plus I have y. It will have fx, gx, hx. We have L, M, N, 0, 0, and 0 I have. So I can say it will be 1, 1 and 1, that is fx, gx, hx. It will be L, M, N, A, B, C. Okay, so that is how we try to differentiate this. Okay, so now let us try to solve next question I have. So what the next question says, let us see. That is 23 now, last question here. So now let us see how we can differentiate that function what they have asked. So let us see. Let us try to implement that. So we have the 23rd question now. So 23rd says, last question of this exercise, that is y is equal to e raised power a cos inverse x. Okay, where x lies between -1 to 1, and we need to prove that 1 minus x square d2y upon dx square minus x dy upon dx minus a square y is equal to 0. Okay, so we need to prove this. Okay, so first of all, what we can do, we need to find the dy upon dx of this. So it will be e raised power a cos inverse x. Now differentiation of cos inverse x will be into 1 minus x square under root, and we'll have a here as a constant term here. Okay, so that is how now we have find that dy upon dx. Okay, so now dy upon dx is this, so we can put here. But now what we need to do is we need to find the d2y upon dx square. Okay, so we have, now what we can write is as it is minus ay upon 1 minus x square. Now what we can do here, squaring both sides. What we'll do here, squaring both sides. What we'll have here, that is dy upon dx whole square will have a square y square upon 1 minus x square, or I can write is that 1 minus x square dy upon dx whole square a square y square. Okay, so now what we can do here, we try to differentiate it. Okay, differentiating with respect to x, what we have, 1 minus x square into 2 into dy upon dx into d2y by dx square, plus I have, it will be minus 2x into dy upon dx whole square is equal to 2 into y into a square into dy upon dx. So here I have applied the product rule to differentiate. Now what will I have? If I take 2 common here, it will be reduced by here. So now, and we'll try to dy upon dx also, we'll try to take common from there. So what I got here? 1 minus x square into d2y upon dx square, because now I have taken common 2 dy upon dx. Here I have minus x into dy upon dx whole square we have. So it will be 1 only, because now I have taken dy by dx also common. So here I have 2y a square dy upon dx. So I have reduce this. So I have 1 minus x square d2y by dx square minus x dy upon dx, well, minus ay square is equal to 0. That is equal to RHS. Okay, so what they have asked, we have proved. So that is how we able to solve the miscellaneous exercise. Okay, I hope it's clear to everyone. If you have any doubt, you can ask, comment, and please share my channel, and also subscribe to it, and please like my channel also.